Well, good day, class. And today we're going to be taking a look at section 3.5 of the textbook. It's titled Quadratic Models Using Factored Form, which we've already seen before. So I've taken the liberty of including a couple things on the handout. As you can see in the graph below, I've already plotted some points, which I'll talk about. So we're going to be just taking a look at some word problems and connecting them to factored form for quadratic, which I'm going to go ahead and type just as a reminder so that you remember what it looks like. And we'll go ahead and insert the equation that represents factored form, which you should remember is y equals a, that's the lead coefficient that we talked about, x minus r, which is one of your zeros, and then x minus s, which is another zero. So that's the general form for a quadratic in factored form. So as you can see here, what I've done is I've plotted some points. So oftentimes the textbook will show you tables of values that are given to you in this format. So you have to realize that usually the first row is your independent. So I'm going to go ahead and label that. Go, and then the height would then be plotted on the vertical axis as your dependent. So I've already gone ahead and plotted these points, and as you can see from the general outline and the shape, even if I insert or draw a connected shape in there, let's try picking a pen in here. So I'll do it from this angle here. Let's see. So I'll just connect those points and kind of roughly see if I can get it to kind of look like a parabola. Not bad, not great, but not bad. So part of the task is to take this data, as you can see here in the message, take the data below and represent the path of the soccer ball as it flies through the air, create a scatter plot, and then determine the equation for a quadratic of good fit. So a couple things we need. We need the zeros and we need the a value. Now this is a little tricky simply because we don't really have the zeros. Now we can really guess wildly if we'd like, which isn't necessarily a bad thing, but I'll talk about another way to maybe not guess wildly. So let's do a couple things here. So we can simply just, we'll call this one a rough estimate. So what we're going to need then is the equation. Oops, I'll type it over here. Not sure why it's not appearing there. There we go. So y equals, and I don't know the a value, but I know because it's opening downward, it should be, pause for effect, should be negative, right? Good. So x take away. Now it looks like one of the zeros happens to be somewhere about here. Let's see if I can get a nice dot in there. So it looks like kind of -1, pretty close to it anyways. So I'll add that to here. And the other one seems to be roughly 5. At least, whoops. That's where I kind of estimated it as anyways. So we don't have a complete equation just yet, but it does seem to work for the most part. So let's just simplify this a little bit more. So I think I'm going to have to insert another equation here. So y equals a bracket. So this will turn into x plus 1. This will stay as x minus 5. Now, in order to complete the equation and find that a value, we need a point on the graph. You can use any point that the green curve is passing through. So why not use one that's convenient? So the intercept seems to be convenient, 0 and 1. Why is it convenient? Well, it allows me to put in a 0 for x and then a 1 for the y value. So I'll go back to insert that equation. So if I'm going to replace the y value with a 1, why am I doing that? Well, that's because this is your y value right here. And this is your x value. So in this equation here, I can then use it to determine my a value. Simply by replacing the numbers that I have with the numbers that I don't have. All right, so from there, I can then solve that equation, which shouldn't be too difficult because 0 plus 1 is 0. Sorry, 0 plus 1 is 1. And 0 take away 5 is negative 5. So this gives us a 1. And again, I'll insert another equation here. 1 equals a bracket 1. Part of negative 5 there. Oops. So that leaves me with 1 equals negative 5 a. Oops, that's not a. So it looks like we can finally solve for a. And I'm going to get a little fancy here and insert the equation again. I have to get a little structure here. You need a little fraction. There's a simple little fraction. So you take the 1 and divide that by a negative 5 to get my a.